I'm Gayatri. I'm working in SNS College of Technology in EC department. Today we are gathered here for taking the design thinking video, which is the application of network theorem for the subject circuit analysis and devices. In the design thinking video approach, we are going to discuss about the network theorem detailed in the 5 stages. That is empathy and the define part and ideate and prototype and test part will be discussed in the network theorem. Students, we can now discuss each stages of design thinking individually.
Okay, today we are gathered here to see about the application of network theorem based on design thinking approach. Design thinking approach is nothing but it is a problem solving approach. It involves human-centered empathy and it is an iterative process to get the accurate solutions. Okay, it involves 5 stages: empathy, define, ideate, prototype and test. Let's see about the empathize part. What is empathize? It is about the understanding the problem. To that, let's see who are the stakeholders of the application network theorem. The stakeholders are the electrical engineers and power distribution companies, and consumers are the stakeholders. Let's see the pain points. Difficulty in determining the voltage and current source in complex circuits, and minimal visibility into network performance leads to potential safety hazards, and need for accurate calculations to ensure reliable power supply.
On seeing the define part, first the main motto of the define part is to identify the problem statement and the main creator of the problem statement. Then by seeing the part of the topic is, first we need to identify the key objectives, where we need to develop an interface by implementing the network theorem, which makes the users to understand by using a visualization of visualization of the network theorem. Second is by using defining the problem statement, where the problem statement should be created by using a user-friendly tool which accurately applies the network theorem and which reduces the complexity of the electrical circuit of the network analysis. This is the motto of the define part in network analysis part.
So ideate. In design thinking, ideate refers to the phase where teams generate a wide range of simple creative ideas and solutions to a problem. In that, we have to define the challenge first. We have to clearly articulate the specific challenges in circuit analysis, such as simplifying the complex circuits and predicting the behavior of the circuit or optimizing the performance. And we also have to focus on the user centered, like identify the end users to identify the end users of the circuit analysis tools or methods, like whether it is used by the students or engineers or some other people, and from there by pain points and their needs. And we also have to consider some questions while solving these problems, like what tools or visual aids we can that can help in minimizing the circuits, and how can we automate the application of network theorem in circuit analysis software.
Prototype refers to an early version of a product which executes before version of final output, and the creation of a prototype is developing a minimal version of a product with following features. It includes user input for a network theorem such as loads, nodes, and branches. Algorithm for applying the network theorem such as KVL, KCL, and Thevenin's theorem. It includes the basic visualization of the network theorem, and use a prototype tools such as Adobe and Figma. It includes creation of clickable and interactive prototype. Okay, at last we had made the brief discussion about the design thinking approach on the application of networks theorem. The main purpose of the network theorem is to reduce the complexity of the circuit. When we have listed some network theorems, that is Thevenin, Norton's, and Superposition and maximum power transfer and duality. There are a number of networks theorems. In each complex circuit, we can deploy any of the theorem so that the complexity of the circuit will be reduced and the equivalent circuit of the complex circuit will be calculated. When we are using the Thevenin theorem abdina, next we can have the solution for Thevenin resistance as well as Thevenin voltage. When we are going for Norton's theorem means we can find out the Norton's current as well as the Norton's resistance, as well as when we are doing some superposition or a maximum power transfer theorem, we can solve superposition equivalent circuit, and also by the network theorem we can easily find the current and voltage of the complex circuit. Okay, thank you students, thank you for the discussion what we have made. Thank you.